Welcome back. In this video, we are going to go ahead and add the coroutine functionality that will help us to achieve the following thing. So once we touch this trigger collider here of our winning box, what I want to do is a couple of things. I want to change the color material of the winning platform. I want to enable the winning UI, so displaying this text because currently it's disabled. Now it's disabled. Then I want to slow down time, wait for a few seconds and reload the scene. So for now I want to just wait, let's say 3-4 seconds and then reload the scene so that the player can play again. In order to achieve this, we're going to use coroutines. So I'd say let's look at coroutines real quick. All right, so when you call a normal method, it runs to completion before returning or finishing its code. This means that any action taking place inside a method must happen within a single frame update. A normal method call cannot be used to code a procedural animation or sequence of events over time. So, as an example, consider the task of gradually increasing a sphere's scale, so its size, until it reaches a certain value. Let's see how such a feature can be implemented using a coroutine line by line. First, we need to define a method that its return value is of type IEnumerator. IEnumerator is a .NET or a C# type that is used to fragment a large collection or files, or simply in our case to pause an iteration. This is all what you need to know about IEnumerator in order to write a coroutine, since IEnumerator is a big topic that is outside of the scope of this course. So here we define the two floats. A target scale, which is the maximum scale we want to reach, and the growing speed, which is the rate at which we will gradually increase our scale over time. Then we stored our X scale inside our current scale, just to make our code look cleaner. There is no reason why we picked the X scale, since this is a sphere. Our scale on the X, Y, and Z axis are the same, so we just picked one of them. Now inside of a for loop, we started from our current scale. We will keep going until our current scale reaches our target scale, and each iteration we will increase our current scale by our growing speed. So now we simply set our scale to our new scale, which is the current scale I times the vector 3.1. As we said, it's a sphere, so we want our scale to be the same on every axis. Now here's where all the magic happens. The yield keyword allows you to create an IEnumerable in the form on an iterator block. This will make the compiler generate a state machine that keeps track of how far the enumeration of an enumerable has progressed. In short, simple words, the C# yield keyword allows many calls to a body of code that knows when called to continue where it left off. And since this method will be called many times in the background until our condition is met, we are telling it to wait for a specific amount of time between each call using the return new wait for seconds, in this situation the growing speed of 0.01. And that's all the code that we need. Now to call or start this routine, cast our engorgio spell like this. Start coroutine and then in brackets engorgio. This will use the command inside the start method. And now just prepare your wands and enlarge something with your magic stick. So let's use coroutines in our project. Therefore, let's go back to Unity and let's create a new script. And I'm going to call this script winning script, just like so. And then let's open up this winning script once it's ready. And inside of this winning script, I will need, first of all, the material that I want to display once we won. So the winning material. So let's create a private material called winning material. And then a reference to the canvas to enable it through our code. So I need to have the game object that I can activate or deactivate, which I'm just going to say is going to be called winning UI. So this private game object can be activated or deactivated by our code this way. So now what we can do is we can create our IEnumerator. Okay, so let's go ahead and create it. IEnumerator. We need to use this keyword here. And then we can call our method however we want. I'm going to call this winning routine. And now inside of here, I need to get the winning material. So I'm going to get the component that holds the material. So get component in here, which will use the mesh renderer, that one here. And then I'm going to set its material to be the winning material. So whatever we have used as the winning material. Now this winning routine is complaining because it needs to return something. So we need to have this yield return at one point. And we're going to add it in a second. So now I want to enable our winning UI, which in our case will just be this text. So let's set the winning UI to be active, which will be this game object here. So set active true. Then I'm going to slow down the game. So this will give us the slow motion effect by setting the time scale of our time class to a fourth of what it is usually. So the normal time scale is 1. And if you set the time scale to something like 0.25, you will slow down the game significantly. And then I'm going to say, okay, once that is done, please wait for 1 second. So what we're doing here is we are waiting for 1 second, but note that every second in real life now is a fourth as fast, so to speak. So it takes 4 times as long. So that means 1 second that we're waiting here. So we're saying wait for 1 second. So this is this 1F, 1 second. But it will be like 4 seconds because our time scale is a quarter. And now we can, once we have waited for this time, set back the time scale to the default value, time scale of 1F. And we can reload the scene. So we're just going to use the scene manager to load the scene in an asynchronous manner. We're going to get the current active scene by its name. And for that to work, we need to import the scene manager. So using Unity Engine Scene Management, we need to add this namespace here at the top. At this point, we can use the scene manager to load our scene, which basically means we are going to reset our game this way. So now we have this winning routine method, and it's not complaining anymore because we are returning something. We are yield returning to wait for 1 second, which will in real life be 4 seconds. And now when do we want to call this method? Well, I'm just going to say we want to call this method once we collide it with the winning platform. Okay, so here I'm going to say if other dot compare tag is going to be the player. So if we hit the player or the player hit this platform, so to speak, then start the coroutine called winning routine. So what we have here is, and winning routine with brackets as well. This winning routine here returns an IEnumerator. But what this really is this is a coroutine. Routine. So when we're calling this start coroutine method, we're just saying, okay, call this method, but because it's not a normal method, because it's a routine, we need to use this start coroutine for this to happen. So this will not freeze our game. This will just run in parallel to our game, so to speak, and will always know when to execute the next line of code and do it correctly. So here it's going to wait for 4 seconds, and then it's going to set the time scale back to 1. But it doesn't mean that it will freeze the game. So it's not like the sleep method that you might know from C# coding. All right, so that's pretty much our winning script. Let's go ahead and test this winning script by assigning it to our winning platform. So let's go over to our winning platform. Let's assign the winning script. We can drag it over here like so. And now what we need to make sure is that we have the winning material that we want to use. So by the way, something that I haven't taught yet is this feature up here. So there's this little lock. I can lock it. So now the inspector will always be locked to the winning platform. Even if I click onto other items like the wall, now I can jump around in the UI or in my scene without changing what the inspector is focusing on. So the inspector is still using our winning platform. And now I can go over to my third-party scripts here to the materials and just say, okay, if we won, let's change the color to be black, for example. So the winning material will now be my black material. And then the winning UI should be my text. So I'm going to say activate the text if we won, and that's what my winning script will do. So we need to assign the winning UI, which in my case is just a text. Okay, so now let's unlock our inspector again, like here, and let's run our game to see if we can actually win the game once we touch the top of our winning platform. You see, they see me roll it, comes up as the text, the game is slowed down, and then at the same time, after 4 seconds, the game is reset. So we can play another round. Now, of course, instead of resetting, you could send the player to the next level and then basically create your own platformer this way. All right, and that's it for this project for now. If you have any big wishes, what we should add to this chapter, please let us know in the Q&A. And well, I wish you a nice day. See you in the next project.